Over 15 hauler towers collapsed in New Zealand during the period of 1994 to 1995. The most frequent cause was the use of guy line anchors of insufficient strength. Whatever type of anchor is used, ultimately it can fail. The answer is to select the most appropriate anchor and ensure it's used in the right way. If this is done, other parts of the rigging configuration, such as the strops, should fail first, leaving the tower and guy lines intact. This program has been designed to illustrate the most common and practicable types of anchors for securing hauler towers. In it, we focus on harvesting Pinus radiata forests in New Zealand. Although this program emphasizes anchoring systems for securing the hauler tower, these techniques can be used for tail hold, corner, and tail block anchors. Secure anchors are essential for cable logging operations. The most commonly used type of anchors are stumps because they're cheap and readily available. The force that a stump will resist is difficult to predict and traditionally has been determined by pulling on them until they fail, then picking up the pieces and counting the cost. This is what we call experience. The older, more experienced loggers are the ones who've pulled out the most stumps. There's no reliable means of predicting the load-bearing capacity of stumps because of variations in root systems which grow differently as soil moisture, density, and slope change. There are, however, some general rules of thumb. The anchorage capacity of stumps tends to increase in strong clay-type soils. In contrast, stumps can have very poor anchorage capacity in sandy-type soils. The contractor who formed the roads and landings will have a good knowledge of the soil and stump strength at each particular landing. Anchorage capacity of stumps tends to increase with soil depth. For example, stumps in deep fertile soils have large, deeply rooted root systems and anchor considerably better than stumps in thin soil overlaying rock, whose root systems barely penetrate underground. Anchorage capacity of stumps tends to decrease as soil moisture increases. Anchorage capacity of a stump increases approximately with the square of the stump diameter. For example, if you have the option of using a 30 or 60 centimeter stump to use as an anchor, 30 centimeters squared equals 900 and 60 centimeters squared equals 3,600. So although the 60 stump is only twice the diameter of the 30, the 60 centimeter stump has 4 times the anchorage capacity. However, a study carried out by LIRO found that over their range of stump sizes tested, anchorage capacity increased with diameter. But within the range of stump sizes, there was considerable variation in anchorage capacity for stumps of the same size on the same site. Stump selection skills acquired through experience of what has been sufficient in the past can therefore be unreliable. Stumps have greater holding capacity when pulled uphill and into the slope, compared to being pulled downhill and out of the slope, because there are normally larger roots on the downhill side of the stump, and also because the resistance of a stump to movement is basically gravity acting on everything which that stump has hold of, and the resistance of whatever is in front of that mass. It's very difficult to predict the holding capacity of a decaying stump, and the diameter becomes even less accurate as a strength indicator. Consequently, fresh stumps must always be used in preference to decaying stumps. Road lines and landings are often constructed several years ahead of the cable harvesting operation. Harvest planners must therefore try to leave appropriate standing trees adjacent to landings to accommodate the cable harvesting crew with fresh stumps. Otherwise, the cable harvesting crew will require alternative anchoring systems. Stump size requirements vary with the hauler size of the timber being harvested, the required payload, and the cable system being used. In skyline systems, where bridling may be used, A greater volume of wood is often extracted from each skyline corridor. Subsequently, the forces from the working ropes may impose repeated loadings on the same guyline anchors for longer periods of time. The greater period of use may be enough to work a stump loose, and therefore these systems require the best anchors available. Anchor stumps should be identified before the stand is felled to ensure the appropriate high stumps are retained. Incorrect choking methods can cause stumps to fail by slabbing or shearing the stump off. LIRO researchers have shown that the higher the stump above the notch, the less likely the stump is to slab, and the slower the stump will shear. LIRO recommends that at least 30 centimeters and up to 80 centimeters of stump should remain above the notch. Maintain an open V-shaped notch. Cutting the notch too sharp causes the rope to wedge into the notch tightly and makes it difficult to remove the rope when you've finished. Notches should be cut into the whitewood deep enough to retain the guy line. The notch depth should be no more than 2 times the diameter of the rope which it is to contain, and have no sharp corners which could induce a kink into the rope. Cutting the notch deeper unnecessarily reduces the stump diameter and strength. Ideally, the notch should be sloped towards the top of the tower and then gradually leveled off as it goes around the back of the stump. This method distributes the lifting force which the guy line exerts on the stump around the circumference of the stump, rather than the lifting force being concentrated onto one side. Stumps with large buttresses or of irregular shape should only be notched on the corners. Alternatively, a hole can be bored through the buttress. This accommodates the guy line securely to the stump without severing off part of the main root structure. The rope should have a slight bite induced by the shackle or connector. For every 90 degrees a wire rope is wrapped around the stump, the tension is halved due to the friction between the rope and the stump. The crushing force is at its greatest in the first quarter wrap of the strop, causing this portion of the stump to almost always fail first when overloaded. In this example, 10-ton tension is applied to the guy line, but the shackle would only see 0.6 of a ton. Therefore, in terms of strength, there's nothing gained by wrapping the rope around the stump twice. Wrapping around the stump twice can also make disconnecting a line under tension hazardous because there's no safe side to stand on. When the guy line is tensioned, this method allows the strap to slip around the stump until the tension in both legs of the strap is the same. Thus, the crushing effect on the stump is better distributed, and the likelihood of the stump shearing off is reduced. This method should not be used when the guy line angle is approaching 45 degrees, because the strap potentially could slide up and over the back of the stump, or cause the back of the stump to shear. The double wrap method, when used properly, will hold securely from any normal operational angle, and similarly to the previous single wrap method, reduces the crushing effect, which can cause stumps to shear off. However, if the legs of the strap are not exactly the same length, one leg will carry the total guy line tension. This could have a detrimental effect if the strap has a lower safe working load factor than the guy line. Balancing the tension in both legs of the strap is time-consuming and difficult to achieve. Stumps are elastic, or in other words, will flex or move when loaded. If they're loaded within their elastic range, they'll come back each time they're unloaded. When the load imposed on the stump exceeds the strength of the root system and/or the mass of material which the root system has hold of, then the stump will pull out of the ground. From research done in Oregon State University and in New Zealand, we've found that the initial movement of the stump as it's loaded is forward, and then it tips up as the load continues to increase. Although this depends on the height above the ground, the pivot point that the strop is attached to. If it's too high, the leverage on the stump will be such that the stump will rotate out of the ground, thus negating the positive effect of having a massive dirt in front of the stump. If the holding power of the roots is greater than the strength of the stump where the guy line's attached, then the cable, or guy line, can pull through the wood and the stump will shear or slab off. If the vertical or lifting force exerted on the stump by the cable is greater than the strength of the wood, then the wood above the notch will slab, allowing the cable to pull up and over the top of the stump. When choking a stump, the newtons per square centimetre exerted onto the stump follows this general relationship. The pressure equals 2 times the cable tension divided by the diameter of the stump times the cable diameter. For example, if the cable diameter is 2.86 centimetres, 1 1/8 inches, the safe working load is 221,706 newtons, and the stump notch diameter is 102 centimetres, the resulting force exerted onto the stump will be 1,519 newtons per square centimetre. With the strap wrapped once around the stump, the equation's the same as the previous choking method, except the cable tension's halved. The resulting force is 760 newtons per square centimetre. A wrap and go back is accomplished by tying the end of the guy line, or an extension, back to several stumps. The stumps must be notched to contain and maintain the line in an exact position. The line should enter the notch at the bottom of the front stump, spiralling around the stump and exiting above where the strop entered. The end of the strop is choked to the back stump. A rule of thumb is the second stump will feel approximately 1/3 of the tension in the guy line. And if you tie back to 3 stumps, the third stump may only feel as low as 1/9 of the tension. Therefore, tying back to more than 3 stumps is often no stronger. Here are the same 2 stumps and tower position, but with the line on opposite sides of the front stump. Note the guy line in figure A is in lead with the tower, but the guy line in figure B has a bite induced into it, which will result in the front stump uprooting sideways or shearing off. Similarly to the wrap and go back method, select 2 high stumps which are in lead with the top of the tower. The front stump is tied back to the back stump using straw line, and the guy line is choked to the front stump. The straw line must be above the load line on the front stump and low as possible on the back stump. The end of the straw line is secured by tying it off onto itself, or clamps can be used. Wrap the straw line around the stump until it's equal strength of the guy line. For example, an 8mm straw line would require 5 wraps to achieve the same braking strength as a 26mm guy line. Use a strong sapling or sturdy limb of sufficient strength and diameter for the twister stick. Twist the lines until firm and securely lock the twister stick. The straw line must not be over-tensioned. Stumps are elastic, and to utilize the front stump's full holding capacity, it should be able to move forward slightly before the second stump starts to fully share the load. If the stumps are twisted together too tightly, the back stump will take all the strain, and the front stump will effectively just float. If you think 2 stumps will still be inadequate, twist more stumps together until the required holding strength is obtained. Ensure that the stumps are kept in lead with the direction of pull. When using multiple stump anchors, it can be difficult to get each stump to share the load equally. However, by using a strap and an equalizer block, the load is shared between each stump exactly. The angle in the strap at the bridle block determines the tension in the strap and the subsequent load on each stump. Tension in the bridle strap is calculated using trigonometry. Tension in the guy line or load line divided by 2 times cosine of the internal angle divided by 2. For example, if you have 10,000 newtons tension in the guy line and the internal angle is 50 degrees, the resulting tension in the bridle strap will equal 5,524 newtons. If you change the internal angle from 50 to 100 degrees, the resulting tension in the bridle strap increases to 7,812 newtons. From these examples, you can see that the legs of the strap should be wrapped from the inside of each stump to minimize the angle between the two legs. This reduces the tension in each leg of the strap and subsequently reduces the load imposed onto each stump. Multi-sheaved blocks can be used if more than 2 stumps are required. A gill poke is a rigid brace between the main anchor stump and some other load-bearing structure, usually another stump, which transfers some portion of the load from one stump to another. In logging, this brace is usually a short log, which is cut to length on site. The back stump is notched at its base to accommodate the guy line. A flat face is cut into the top of the back stump and another into the base of the front stump to accommodate the stay. The stay should be installed firmly between the 2 stumps. The most common deadman used in New Zealand consists of a log or logs buried in the ground. The holding characteristics depend on the frontal area of the log and the amount and type of soil in front of it. Maximum benefit from a deadman is attained when an excavated area is held to a minimum. This is best accomplished with an excavator-type digger. The deadman log should be at minimum 5 meters long and buried at least 4 meters deep. Larger deadman logs should be used in friable type soils. Form the trench at right angles to the line of pull, with the front wall as vertical as possible. A notch is cut out of the front wall of the trench to accommodate the guy line strap. The strap is laid into the trench with the 2 ends projecting. The log is laid into the trench and the 2 legs of the strap are placed into the notch in the side of the trench before being backfilled and compacted. Tension the guy lines and then paint the strap where it comes out of the ground. The paint mark is used as a reference point to detect if the deadman is moving. Tractors make excellent anchors, providing they're of sufficient size and are equipped with a blade. To ensure the tractor's secure, the blade should be at right angles to the guy line and secured behind a stump or mound of soil. Excavators are more commonly used as tail anchors for the operating ropes, rather than guy line anchors, because the dipper arm allows the ropes to be attached several meters above the ground, which provides added deflection. Stumps must be fresh, of sufficient size, have deep, firmly anchored root systems, correctly notched and tied off onto, have sufficient height of solid wood above the notch, and be located on the correct aspect. Multiple stump anchoring methods are twisters, wrap and go back, equalizer block, and gill poke. And if there's any doubt of the adequacy of stumps to support the hauler tower, use machine anchors or deadmen. This program is not a standalone training video. It's an overview of commonly used anchoring methods in New Zealand. with particular emphasis on the processes which contributed to over 15 hauler collapses during the period 1994 to 1995. Nor does this program set out to suggest one method is better than another. This program is merely developed to help cable loggers choose different methods knowingly. Successful cable harvesting requires a great deal of innovation. Rock bolts and artificial earth anchors, to name a couple, have been successfully used in situations where other anchoring systems were less practical. Whatever anchor system you're using, daily checks should be made to detect signs of failure, thus ensuring the stability of the hauler tower. Before using any of these anchorage methods, we recommend you contact LIRO Limited or a Logging and Forestry Industry Training Board cable harvesting accredited trainer for one-on-one practical training.